Hello and welcome to the SANS APAP webcast series. My name is Ruby Souza and I will be moderating the webcast today. Your presenter is Justin Searle. Please feel free to submit your questions at any point by using the questions tab, and a brief Q&A portion will take place at the end of the webcast. Thank you for your attention. Now let me turn the mic over to your presenter, Justin Searle.
Thanks, Ruby. And everybody, welcome to this little update that we're going to be giving on ICS 410 and all the updates we have made for 2019, as well as a nice little discussion on how to deal with remote access to critical infrastructure and other highly sensitive networks. So basically what we're going to be covering today is we're going to go ahead and first go through and show you a little bit about architectures, network architectures in industrial control system networks and plants. And as the process, show you that for the 2019 update to ICS 410, how we have updated all of our architectural models and our reference model for what we consider to be a secure architecture for control systems. Leveraging, of course, IEC 62443 and all the other industry guidance, but just trying to put it together into one single usable model. So let's go ahead and get started. So first off, if you work inside of ICS or have spent any time inside of industrial control systems, you should be familiar with the PERA model, right? We usually call it the PURDUE model. The PURDUE model was actually a subcomponent of the Purdue Enterprise Reference Architecture, right, or PERA. So PERA is the official name, but everybody calls it PURDUE. And if you look on this slide on the right-hand side, you'll see an example of what that PURDUE model is. So the original PURDUE model had nothing to do with cybersecurity. The PURDUE model originally was created to provide manufacturing organizations a logical method to organize their equipment and their machinery in a manner that isolated problems with some of the technologies, right, and facilitated change and growth inside of a factory. So the original PURDUE model broke it into 5 different levels. They were numbered from level 0 all the way up to level 4 at the very top, right? So let's go ahead and look at the very bottom of that PURDUE model on the right-hand side of this slide. In the PURDUE model, they prescribed 3 different levels that made up your control processes themselves, right? Didn't matter if it was a batch process or a continuous process or a discrete process, or even some type of a hybrid process. It didn't matter how small or how large that process was. What the PURDUE model did is it subscribed or suggested we should take all of our processes, right, and individually group all the elements or all the systems for each of those processes in a single group. And then in that group, divide that group into 3 different levels, right? With level 0 being the very bottom, right, where your individual process or your individual manufacturing cells or manufacturing lines had their sensors and their actuators. Level 1 was for the controllers, be that some type of a PLC or a DCS controller or some other type of machine controller that was there, right? So regardless of the controller, even if you had multiple controllers in more of a hierarchical fashion, which we quite often do with DCS systems, right? That would be all considered PURDUE level 1. And PURDUE level 2 was going to be the supervisory equipment, right? So your HMIs, your historians, if you have a historian unique to a single process, but that would be supervisory per process, right? So on this diagram, some people get this confused in the original PURDUE diagram because it shows levels 2, 1, and 0 at the very bottom, and then it shows 3 circles, batch, continuous, and discrete. And most people mistakenly think that they were trying to imply that batch was number 2, continuous was number 1, and discrete was number 0, which was definitely not the intent. What they were trying to do is that each process should be grouped, right, in some type of a logical grouping, or maybe even associated processes next to each other. So think of like a manufacturing floor. We have different manufacturing lines. Each manufacturing line would be grouped into their own separate process or cell, right? And then we would designate all the equipment having to do with that process into its own level 0, level 1, or level 2 for that process, right? That allowed us to isolate each manufacturing line or manufacturing cell from the other ones, right? So if we had some problem in one manufacturing line, hopefully by isolating each process, we didn't have any bleed over or any type of cascading failure from one process to the next process. Now above that, we had level 3. Level 3 in the original PURDUE model was called the manufacturing and operations and control level, right? This is where they did dispatching of what was being manufactured, right? Detailed production records, scheduling, other types of basically plant-wide operations and plant-wide control. So if I had something like a historian, right, that was kind of a higher level historian aggregating all the details from all the processes, that would go into level 3. If I had some type of a plant-wide HMI, human machine interface, that showed me how all the processes inside of the plant were working together, right, that would be considered a level 3. So always think of level 3 as that plant-wide, and you can see that very visually in this graphic. And then level 4, higher up, right, that would be what we call the business planning and logistics. That would be what we generally say is more the business network, things that are not directly impacting the processes themselves. So if you have a server that can send a signal to an individual process to change operations, right, that would be a level 3 type system, because that's the level 3 plant-wide control. But if it's something simply trying to do operations management or higher level scheduling, right, that would be generally more of a level 4 business process, because those machines in the business network are isolated from the rest of our control, and more of that enterprise type level or the business network at the plant, but not really the control network, right? So another way to think about it, anytime we talk about a control network would be something between level 0 to 3, because they all have to do with control. Level 4 is not considered one of the control networks or the ICS networks, right? That level 4 is going to be simply business machines that happen to reside at the plant for business purposes. Okay, so that kind of gives you a little bit of background inside of the PURDUE model if you weren't familiar with it. As for the original PURDUE model, as I mentioned, it had nothing to do with cybersecurity. However, that did change over time. ISA 95 was one standard that went ahead and adopted the PURDUE model in a very formal fashion as suggestions and built more guidance around how we should deploy the PURDUE model. But still, ISA 95 had nothing to do with cybersecurity. It was still primarily focused on the technology of manufacturing. ISA 99 was a later project that came through, right, in the early 2000s, and ISA 99 was the very first time that they tried to prescribe cybersecurity features or defenses to that PURDUE model. ISA 99, after they were up and running for a period of time, right, eventually ended up joining forces with IEC and established a joint effort, which we now usually refer to as ISA IEC 62443. And really 62443 from a cybersecurity model is the current iteration of the PURDUE model with cybersecurity guidance built into it. So kind of a lot of background there, but really if you're interested in taking ICS 410 or have already taken ICS 410, most of our course heavily leans on the guidance from IEC 62443, as well as other guidance that's out there. And one thing we've tried to do in our class, since 62443 is something that is something you would have to pay for and not technically 100% complete yet, right? It is a fairly expensive standard to purchase. What we've tried to do in ICS 410 is create our own reference model using the guidance from 62443, but also from other references and other security guidance documents from around the world, different government documentation and other standards bodies, and try to adapt all that into a single reference model we can use for class. So we have kind of a single set of guidance, right, that everybody can go ahead and use. And that's what we're going to go ahead and look at. Now, since we are talking about cybersecurity, one of our very first layers of defense in any control network is going to be that outside perimeter. Our goal inside of control is to prevent even one malicious packet from ever reaching any controller, right? That's just general guidance that we want to try to do. That's always our goal. We should assume that if an attacker can get to a point in our infrastructure where they can send one single malicious packet, we should assume that attacker can have full control over that process. So that's what we want to be careful of. Keep those malicious packets away from the controllers. The controllers are really hard to defend, so our best defense is to keep all the maliciousness further away. And we want to do this with different layers, right? So our very first layer is that perimeter between the business and the enterprise, and our control networks, right? So our control network should be isolated from the business and the enterprise networks that's there. Remember, hard and crunchy on the outside, soft and chewy in the middle. It's a joke that we often talk about inside of cybersecurity, right? For networks, well, just remember, there's no network more soft and chewy than a control network, right? So we want to have a strong perimeter, and then once we have a strong perimeter, we want to start building sub-perimeters in our control network. So eventually we have multiple layers of defense, keeping those malicious packets away from the controllers that reside at layer 1 of our PURDUE model, okay? So very first thing, if we're going to look at that outer perimeter, we're going to look at the demilitarized zone. So here's a diagram that actually comes from NIST 882, right? So 882 is one of the NIST documents that provides guidance for industrial control networks. And that document calls out the need for having some type of firewall or strong perimeter between the business network, which in this diagram is the upper left-hand corner of the diagram, and the control network, which is the rest of the diagram that's surrounded by the dashed lines. Okay, now 882 calls out saying that we should have not just a firewall, but for a strong perimeter, we should have a demilitarized zone between the business network in the upper left and the control network in the lower right of the diagram. Okay, and we can see in this diagram they have placed firewalls on either side, and this allows us to control everything going into the control system DMZ and out of the control system DMZ inside of this environment. And the general guidance from 882 says that we should make sure that all traffic between the control network and the business network should always stop at some server or service in the control system DMZ. That basically no single conversation should ever occur directly between a system in the business network and a system in the control network, right? They should not be talking directly to each other. They should always send their information to the control system zone, and the other side should pull it from the control system zone, right? So that's the foundation of having a strong perimeter inside of our control network or around our control network, right? And we often end up with two firewalls because it's more of a political battle with IT and enterprise security teams, right? If we have a firewall, they want to have control, so we give them one firewall on one side, on their side, and then we have a second firewall that's usually controlled by a cybersecurity team that is a dedicated cybersecurity team for the control networks or the ICS infrastructures that's there, right? So that's why we often end up with two firewalls. I'm actually totally okay with a single firewall solution, right? So a firewall with 3 legs where the demilitarized zone kind of hangs off of its stub on the middle leg of the firewall. I'm okay with that architecture as long as it is only managed from the control system side and you have some type of a business process to ensure that no rule ever gets added to that firewall that allows direct communication from one side all the way to the other side. Everything should stop at that middle leg, that control system DMZ. Okay, so that's strong perimeter. Now let's go ahead and take this a little step further. What we've done inside of ICS 410 is we've tried to take that guidance from the PURDUE model, right, from 62443 and from 882 and start combining them together into a little bit more detailed view. And that was one of the big updates that I did for ICS 410 this update, is I wanted to provide a better visibility and better understanding of what our control centers could look like if we had strong internal boundaries inside of our network. So we can go ahead and look at this diagram. This is kind of the high-level diagram of a medium to large organization that may end up having many different plants, right? In the bottom left-hand corner represents a plant network. And then this also represents an organization that may have a SCADA network, right? So like an oil company or a gas company or electric utility or a water company where they end up having other types of substations or outstations or field sites, right? The terms vary from business to business in the countries around the world that you're in, right? But in the SCADA network, we usually have external sites that are all feeding information back into the SCADA WAN and then back up to our control centers. So this diagram tries to demonstrate that. When we try to map something like this larger, more complex SCADA network to the PURDUE model, right, we have to kind of be careful. Sometimes there's some confusion there. And many companies will map this differently. So don't be surprised if a company that already is using the PURDUE model with a large SCADA infrastructure, don't be surprised if they have labeled things a little differently or have assigned their PURDUE levels a little differently. Part of the problem is there's never been good solid guidance consistent across the board, which is one thing we're trying to rectify here at ICS in the ICS 410 class, is to try to standardize on a model here. Okay, so if I look at this at the very highest level, up here at the very top where this internet DMZ is, right, that's the external perimeter for the company. PURDUE level 5 would be the enterprise network and all the enterprise services that are being provided to the company that's there. And then below that, we end up having several different sites, right, with ICS or control traffic. Here I end up having control center A. So this is one control center, right? Control center B is another control center. And here I even have a dedicated data center for ICS, or a control data center, right? ICS data center, control data center, however you want to term that. This might be at one of the same sites as one of the control centers, but maybe it's a different site. I kind of demonstrated as a little different site here. Now, of these, we end up having these 3 higher level sites, which we would generally refer to as PURDUE level 3 inside of the PURDUE model. Because once again, remember, PURDUE level 3 is kind of that higher level management and control of our control infrastructure. And so if level 3 at a plant is a plant-wide network, when you look at SCADA architectures, that control center, which controls the whole regional SCADA infrastructure, becomes the level 3 or the SCADA-wide control level, right? So we generally say control centers are PURDUE level 3. If you have some type of an ICS data center doing shared services for your control infrastructure, that would also become a PURDUE level 3 type resource that's there, right? Then looking at the very bottom ones, notice the plant. The plant does have a level 4 network, and then it has its own little demilitarized zone. And then we have that plant network below it, which is the ICS network, right? Or if you want to use the 62443 terms, that would be the control zone inside of the plant, right? And then you have level 3 down here inside of the plant. And then we end up getting into level 2 and level 1 and level 0, and then all the way down to our safety systems inside of the plant. So our plant's going to have from level 0 to 3, just like we saw in the PURDUE model, and it's going to have, probably most plants will have a business network with business assets there, which would be level 4. Notice that it has its own demilitarized zone. Notice that we have demilitarized zones between the enterprise network, right, and possibly business networks that are at the same site, right? If this control center is at a physical building where they do have some business machines, that would be the equivalent of a PURDUE level 4, right, at that. But regardless, anytime we come from the enterprise, notice that we're always passing through some demilitarized zone, ICS demilitarized zone, going into each one of these different areas that's there. Okay, so that kind of gives you the high level perspective of this model. Let's go ahead and kind of dig in a little lower. So we're going to dig into that next boundary. But before we do that, let's talk about one quick thing. In that previous model, let me go back here for just a second. Notice I have a lot of these different areas mentioning an enforcement boundary, an enforcement boundary, an enforcement boundary, and a lot of different enforcement boundaries here, right? These enforcement boundaries are going to be areas where we can go ahead and place cybersecurity defenses that will either actively protect by trying to detect malicious traffic and block that traffic, or to limit that traffic, or try to monitor the traffic and create a record of that traffic, allowing us not only to try to keep the attackers out, but to try to detect when the attacker has maybe compromised one of our boundaries or gotten into our environment. Now, on all these diagrams, notice there's many different types of enforcement boundaries that are mentioned there. And we're not trying to prescribe what has to be in every single one of those enforcement boundaries, but we are saying that this enforcement boundary is a place where you can do cybersecurity controls. This is where you can monitor. Now the trick is trying to figure out what types of cybersecurity controls to put in each one of those different types of boundaries. Because some cybersecurity controls may be very appropriate in one boundary, but not appropriate in another boundary. And that's based purely on the technology and the requirements of your control processes themselves. And that's something that we try to do inside of ICS 410 over that whole 5 days, is to try to help you understand in 5 days what types of cybersecurity controls are appropriate in each one of those boundaries, as well as with each asset in each one of those zones, and which ones are not. So that way you're better prepared to try to make educated decisions on what types of security controls go in each location. Regardless of the controls, two pieces you should always think about when you play cybersecurity controls, especially in these enforcement boundaries. There's two major types of controls that we want to put there. Something, number one, to limit the communication through that boundary, and number two, to try to monitor and record all communications through that boundary, right? So you can use a combination of network firewalls and next-gen firewalls, data diodes, unidirectional gateways. You can, and all those things will allow you to enforce or to limit communications through the boundary, right? And then systems like network intrusion detection systems and network behavioral anomaly detection systems will also allow you to go through and try to monitor and limit that control of data going back and forth. And there's lots of other full packet solutions that you can do for capturing and recording that traffic. You can use NetFlow traffic to be able to do that. And these are all things we covered inside of the course. But just think about enforcement boundaries. These are areas that are choke points, right, where all the traffic kind of gets narrowed down, which is the most strategic area to do that monitoring and control. So let's go ahead and look at this kind of higher level. So levels 4 and level 5. What is level 4 and level 5? Well, remember, this is all part of that whole business environment or the business networks. These are things, level 4 and level 5, that we are not considered part of the control network, right? These are things above that. This is part of the enterprise that's there. We usually break that into two different levels, 4 and 5, simply trying to help us understand the difference, because at many of our ICS sites, we have business machines, right? And those business machines often are very different than necessarily the enterprise services that we have being hosted in some central location for the company, right? So we generally say if you have a plant, so you see this plant on my left-hand side, the business network is level 4 with all of the machines that are there, right? So these are going to be supporting services and HR and email and other types of solutions that might need to reside at that plant, right? But level 4 is the systems, the business systems that reside at the plant. Level 5 are basically all the enterprise resources that are being provided by the enterprise, which we usually have to get to by going through MPLS links through the enterprise WAN back to the enterprise network, right? So a lot of times my internet connection comes through these links. Most of the time our emails, right? The way we access email is to the enterprise email server, right, from the plant network. So we're sitting at a machine in the business network, and we open up Outlook to get to our email. Outlook is actually talking to a server in level 5, right? So all those enterprise type services that's being offered there. So that's level 4 and level 5. Now, some cybersecurity guidelines for level 4. Here's some general rule of thumbs for level 4 at the plant. Internet access and email and any other types of enterprise resources that most employees gain access to or need for their jobs should never go lower than level 4, okay? This means that we do have to provide machines in level 4 for all of our OT or ICS staff. If we have engineers and operators and technicians, if they need to read enterprise email, they are going to have to physically walk to a machine in the level 4 business network at the plant, or possibly, right, maybe provide a second workstation at their desk, which is physically wired to level 4, right? So that way they have access to the email and the business resources. The biggest thing is, remember, we want to isolate our plants from any type of malicious traffic or any compromise. We should have a strong enough security defense that if our enterprise has attackers or is compromised, that does not mean our control network compromised, right? That's the whole reason why we're doing this, is to try to isolate the control center and our control processes from any risks that our enterprise faces. Okay, so and those emails and internet access, that's the #1 way that attackers are getting into these plants, is when people mistakenly provide email and internet access to machines inside of the control networks themselves. So definitely don't do that. Also, another quick note, Enterprise Active Directory should not extend below this point. Quite often, we'll have some type of an Enterprise Active Directory domain that's at level 5 that spans the entire company across all the sites of the company. In fact, at larger plants, we may even have one of those Enterprise Active Directory servers sitting physically in our business network at level 4, right? Which is absolutely fine. That allows all those enterprise machines and business machines access to our general enterprise services. But that Active Directory domain should not extend down into the control network themselves. Even if you have machines that need Active Directory inside of your control network, we should not share Active Directory with the enterprise. If we do, that tends to leak all of our control credentials into the enterprise and creates a trust boundary that attackers can exploit to get into the control network. You do not want to have an attacker that compromises the enterprise Active Directory, which does actually occur quite frequently. We don't want those attackers to immediately automatically have access to the control networks, right? Isolation. So let's go a step lower. Okay, looking at that PURDUE level 4, that's going to be that plant logical network that we mentioned. Any traffic that needs to go from level 4 into the plant, right, into the control network, or traffic from the control network that needs to go back into the enterprise, like all the billing information that we need to do from our processes, right? For processing oil, how much oil we're processing, well, we need to push that to the enterprise. If we're an electric utility company selling electricity to customers, well, our control processes are gathering that information and metering how much each customer is using. All that metering information needs to leave the control network and go back to the business, right? So that needs to go through that demilitarized zone back to PURDUE level 4 and eventually up to PURDUE level 5, where the enterprise financial servers are. So all the traffic going between these, in and out of the control network, needs to pass through some type of an ICS demilitarized zone, right? We can have a single ICS demilitarized zone that we have multiple different servers in, or if it's a larger site, like what you actually see here in this diagram, what we've done in this diagram is shown how at larger sites, we can take that ICS demilitarized zone and actually break it into multiple different ICS demilitarized zones that further isolates and further minimizes our risk. So here I have 4 different ICS DMZs. This is one that I quite often use with my customers when I'm working with them in trying to do secure architectures at large plants, right? The goal here is, if you notice that DMZ on the left-hand side, that shows traffic from the ICS zone, right, ICS network, back to the business. So that's basically all traffic going north, or going from the bottom of the diagram to the top of the diagram. The second one, which is the business to ICS, this is all traffic going from that business zone level 4 down into the ICS. So an example of this is maybe we have patches for our Windows machines that we need to do, or maybe we have antivirus rules or other traffic that we need to get from the enterprise into the control zone. Okay, that should stop by some server inside of the ICS demilitarized zone, and that, by separating these, this basically allows me to further facilitate or make it easier so that only traffic going south or going from the top of the diagram to the bottom goes through this ICS zone. Okay, one of the benefits for separating the northbound traffic from the southbound traffic is, if an attacker compromises one of these machines, right, it doesn't mean that he can use that to get back going the opposite direction, right? Further isolation, further risk separation. Here's another example that we have. So the third one I have is labeled cloud access. One feature that we end up having a lot inside of ICS machines are needing to access different types of cloud deployments or different resources for our vendors or for the solutions that we're purchasing. So by having a separate demilitarized zone for cloud access, this allows me to isolate that cloud traffic and further allows me, inside of this enforcement zone between the ICS DMZ cloud access and the PURDUE level 3, it allows me to have a further additional controls over where that cloud access, if I pull information from the cloud back into the control network, it it allows me to limit exactly where that goes inside of that environment. And then finally, remote access, basically separating any type of traffic pattern that requires bidirectional traffic into its own ICS demilitarized zone. And this one's just for us on this diagram or example is labeled remote access, isolating that remote access in a separate environment that's there. Okay, so that kind of shows how we can set up those demilitarized zone. Now, one of the biggest points that we want to do when we're doing this architecture, if you look at this bottom set of bullet points, is we want to, as much as possible, and it's not always possible, but in a perfect world, right, the traffic models we want to see through all these demilitarized zone is that one side, either level 4 and 5 or level 3, right, will push the traffic that needs to go across these demilitarized zones. They'll push it into the demilitarized zone, and then the opposite side will pull it out. So if I need information from the enterprise to the control networks, right, the enterprise should push that to this ICS to business demilitarized zone, and then the control network, as needed, should pull that information out of that zone into the control network, right? So it has control when it actually pulls into the control network. Same thing, if I'm pushing information back out to the business, excuse me, I did my diagram or my arrows backwards there. If I need to take it from the ICS zone back to the business, then the ICS pushes it to the ICS zone, and then the business pulls it out of that ICS demilitarized zone as it needs to, right? So that push-pull model is what we optimally would like to see where possible. Once again, it's not always possible, but we want to try to form our traffic or to try to shape our traffic in that pattern, because that does provide them the most strength and resilience to our traffic pattern that allows us to do it. Now, if you have a larger plant, right, maybe you want to consider something more than these 4 different ICS demilitarized zones. That might be appropriate to have 5 or 6 demilitarized zones. Or if you have a very small plant, right, maybe it doesn't make sense having this many. Maybe you'll have a single ICS demilitarized zone or maybe 2 ICS demilitarized zones. The biggest idea is make sure you understand how the traffic passes back and forth and understand why we could divide them and the benefits it provides, and then that should help you determine if that is appropriate for the specific deployment that you're looking at, right, which will change from site to site, even inside of a single company. PURDUE level 3. PURDUE level 3 is at plant-wide supervisory level, right? So plant-wide monitoring, plant-wide control, and plant-wide operation support, right? Really, that plant-wide 3 often is a very complex environment with many different types of systems. Previously, in most guidance that's out there, including something like 62443 and NIST 882, right? They say in the text that you can subdivide PURDUE level 3 into different subnets, but they don't necessarily bring that to the forefront with a lot of their diagrams. And so a lot of people don't understand that level 3 isn't a single flat network or a single subnet, but it could be and really should be made up of several different subnets. So here in this diagram in our ICS 410 reference model, I've tried to show you some examples of the different subnets that I've created with some of my customers, right? So here I've broken it into 5 different subnets, that PURDUE level 3. I've broken it into one for the master servers, the historian, the HMIs. Really, that is the plant-wide control, and most of the machines dealing with plant-wide control would sit there in that subnet. And then notice I've also taken all the workstations, because we do have workstations like engineering workstations that are used for control, and technician laptops that are used for control, and workstations for the operators, right? We can create a separate subnet just for workstations. And if you have a lot of staff at that site, you may want to consider breaking that workstations subnet into multiple workstation subnets, right? Depending on how many people are at that site. We have a testing and staging zone. A lot of plants will have some testing or staging infrastructures or systems, right? Maybe some simulation equipment that can go in that testing and staging zone. That helps us isolate that from some of the other control systems that are, or the other level plant-wide systems. And then here I have one for cybersecurity operations, right? If you need to patch your machines, if you need to monitoring the log files on the machines, do centralized logging, or do any other security solutions, intrusion detection systems, full packet capture, net flow data summaries, right? Whatever you need for security operations, you can create a separate subnet in the plant level 3 to isolate or to aggregate all that information back together. as a quick side note, well, actually, let me save the side note for 1 second. And the last one is the jump hosts, right? And you can have jump hosts here. Jump hosts usually are simply engineering workstations that are pre-installed, pre-designed with all the tools and the data needed to do some type of a role or function, right? So a jump host is usually when I connect from remote access, I connect to a jump host, and that jump host has all the software I need to be able to do my job inside of the control network themselves. Now, those last two groups, cybersecurity operations and jump hosts, some guidance that's out there actually show that as part of an ICS demilitarized zone, and sometimes that's appropriate. However, you want to be careful with that. The biggest problem, and part of the reason why I usually recommend putting these in level 3, is if you think of something like the patch management server from security operations. Patch management server needs to talk to every machine in the control network, at least the machines that it's managing patches for. And if you were to try to put that patch server inside of the demilitarized zone, like a lot of the guidance suggests, now we have a big problem, because the firewall rule from that down in the control network basically allows you to talk to basically everything. So it makes your firewalls like Swiss cheese, right? So I like putting security operations in a separate subnet in level 3. That allows me to have a stronger external perimeter, and it also makes sure that anybody doing cybersecurity operations must first securely authenticate to the ICS network first, and then be able to get into that cybersecurity operations area. Just make sure you do build some good defenses around the cybersecurity operations area, because we definitely don't want an attacker getting to level 3 and from there laterally going across into the cybersecurity operations. Okay, level 2, if we could dig a little deeper. This looks at level 2 inside of our plant. So here you can see that I've grouped them into 4 different manufacturing cells or manufacturing lines or manufacturing processes. Once again, the terms do change from company to company and industry to industry. But here I just have 4 different processes that's there. You can very cleanly see that each process does have its own level 0, level 1, and level 2, right? Level 2 is going to be that local supervisory area. That's where the HMIs or the alarm server or process analytics for that one single manufacturing line is placed. So PURDUE level 2 often is going to be more Windows-like and Linux-like machines, but you may still have some embedded systems there at level 2. But that local supervisory are supervisory equipment for only that one process. Now, this is another point of confusion for a lot of people new to the 62443 and the PURDUE model, is they get confused, where does an HMI go, right? Well, it goes in level 2 and level 3. It really depends on that HMI, what is it responsible for? It's a level 2 HMI if it is limited to just one process or manufacturing line or group of manufacturing lines. If it's an HMI for the whole plant, then that's a level 3 system. So level 3 devices inside of that, or the systems, and level 3 systems in the master server historian in the HMI subnet, right here in this network subnet, right, look a lot like the machines we have down here in PURDUE level 2 local supervisory. The only difference is scope of the system, right? Is it plant-wide or is it isolated to one single process? Part of the benefit of doing this and breaking the process into different levels is it allows us to island. So if we ever do have a compromise where level 3 is compromised, right, with the permission and the guidance of the engineer, right, often we can isolate and separate each of our manufacturing or process lines and island them or separate them from the plant-wide supervisory control. Can't always do that. You need a plan for it, and it's always an engineer that makes that call. But islanding is a great defense we do, which one of the benefits to having these isolated into their own zones that's here. Right, PURDUE level 1. PURDUE level 1 is what we call local control. Local control is what we do for where we put our PLCs or our DCS controllers or other types of machines that are there, right? In a SCADA environment, these would be our RTUs, would also sit here inside of this zone because they are controllers. Right? And we would have different level 1s for each one of our different types of processes. And hopefully they're not in a shared network, because once again, having each process separated allows us to have some type of an isolation for each process. So one process that gets affected or manipulated or compromised doesn't necessarily affect all the other processes that's out there. And you can think of any number of the different examples and the known attacks we've seen, like the Ukraine power grid attacks, or SCADA, or the Stuxnet that attacked the Iranian centrifuges that's there, right? By having separate process cells, it basically allows us for more isolation. So if one gets compromised, hopefully the other ones are okay. And in worst case scenario, we can island them off and for temporary amount of time until we can fix the problem that's there. PURDUE level 0, these are our field devices. PURDUE level 0 basically are where all of our sensors and our actuators go. They could be basic sensors and actuators, right? They could be smart sensors and smart actuators. What is a smart sensor and a smart actuator? That's generally what I refer to as any of our field bus devices. So if we have a device that is an actuator or a sensor that, you know, instead of using basic I/O, it uses some type of a protocol, usually some type of a field bus, right? That's a smart sensor, smart actuator. Kind of helps you understand more of the terminology that we often will use inside of the class. Often we end up having things like IoT devices placed at this level, or IED devices, other names that we often place here at that PURDUE level 0. Other field instrumentation also occurs here at this PURDUE level 0. And if you ever talk about field bus networks are usually at this PURDUE level 0 as well. Okay. Also on this slide, if you notice the very bottom, safety systems, something we talk a lot about in ICS 410, which we're not going to go into today, is our safety systems also should have some type of enforcement or air gap, right, to isolate them from the rest of the process. In a perfect world, we'd love to air gap all of our safety systems, so there's literally no way an attacker could compromise that safety system. But in modern day safety systems, we usually have to have some limited communication between the safety system and the local controller. So in that case, we'd want some type of an enforcement to make sure we are limiting what goes back and forth and definitely monitoring what's going back and forth on those systems. Okay, so that kind of gave you a deep dive into the plant. If you want to take a step back now and look at a SCADA infrastructure like an electric utility or an oil company, gas company, water company, right, that's doing some type of a process over a large geographic region, it's the same type of thing. It's just a little different scale. Our PURDUE level 3 is up here at our control centers, which are centrally located usually, right? Often may have a data center that's an ICS data center, and all of them are connecting through some type of a SCADA WAN connectivity to each of the different sites that are out there. Now, the one site could be a plant, right, which is hiding underneath this regional SCADA text box that I have. But each of the outstations and substations are also going to be connected through this WAN link, where all that communication can go back and forth to each one of those sites. And we should have enforcement zones on every single side of where that traffic is coming into or out of for that WAN connected. Because remember, the WAN connectivity is definitely more of a weakness for us, or an attack point for attackers. So we should all be looking for attacks coming or jumping into that WAN into these other areas, which is why we have the enforcement zone. And then for each of the outstations, substations, field sites, we generally will think of that whole site as a single process, right? And the local network that would be at that site, we often will have some type of a local LAN at that each field site. We'd generally say that's PURDUE level 2, right? And then we'd have local controller, the controllers at that site. Level 0 are going to be the instrumentation at that site. And then, of course, that would change for a plant. The plant would still have its own level 3 and level 4, as we previously discussed, right? And our SCADA would simply connect back to one of the demilitarized zones at the plant. Okay. Now, as for remote access is a fun little subject that we have, and we're going to go ahead and cover that here in the last few minutes of our presentation. But remote access is something that is a little tricky for these environments. And part of the reason why we have our architecture set up like this, with the different demilitarized zones and the different subnets inside of PURDUE levels and the enforcement zone between, allows us to have the ability to do more secure remote access. Now, recommendations for remote access. I always recommend a two-step process for remote access. Step number 1, if you have some engineer or some employee or some vendor that needs to get remote access to your plant, right, we would prefer them to VPN from the internet or from the enterprise network, right, into the ICS demilitarized zone. That first authentication and that first step of this remote access process should use two-factor authentication, and it should be authenticating against either the Active Directory server or some standalone authentication server. Okay, so two-factor to get to that very first point. If they successfully authenticate, their machines through that VPN connection should receive an IP address from the ICS demilitarized zone. Okay, so they basically become, if I put my mouse up here on this upper right-hand box, if you can see the mouse moving around, right? When you VPN in, you basically get an IP address in this ICS demilitarized zone. Okay, once you have VPN to that location, you're halfway there, but you're still not fully completed. You need to complete the second stage or the second step of the remote access. The second step of the remote access, I usually recommend to most of my customers, is to have that user either RDP or VNC or use some type of a Citrix connection to some type of a jump host in the jump host subnet of PURDUE level 3. This basically requires them that when they make this secondary connection that they have to authenticate to some type of Active Directory server inside of the control network, right? Or some type of a standalone authentication server in that control network using different set of credentials. So now we have a totally different set of credentials, and these credentials should never leave this environment, right? So they should be safe from attack or compromise. So we want to have a second authentication, right? Using different authentication store into this other environment. Now, why RDP, VNC, Citrix, right? Because these are things we would never expose to the internet, but these are more appropriate for the second stage because we generally should try to harden or lock these services down so that all the software that's on the host of the machine VPNing in cannot be used from their hosts into the control network. Basically, they use an RDP connection or a Citrix or a VNC connection to that jump host. The jump host should have all the software that they need installed onto it, all the data they should need, and they should not be able to bring data with them. They should not be able to bring applications with them, right? They have to use the software on the jump host, not the software on their laptops that they remoted back in. And once again, that's a way to isolate the malicious stuff that could be on their laptop, preventing that from getting into the control network themselves. You know, think of it as kind of that safe room where in most plants, you have to enter some room and change your clothes, change your boots, and go through some type of a cleanliness process so you're not infecting the plant. That's more or less what we're asking for remote access and all the data that's there. Now, sometimes a vendor or an engineer may need to bring data with them. In that case, at that very final bullet point right here, some separate scanning solution should be used. So if they need to bring data with them, once they have VPN'd in, they can from that point then upload that data to some type of a scanning server, connect to the jump host, and then from the jump host, connect to that scanning server to pull whatever software data that they need down from that scanning solution once it has been approved. Okay, so that's what I recommend for security mode access. It doesn't always work. Not all vendors will agree to this, right? But this was what I would recommend for all of our internal customers and what we try to push all the vendors towards if we possibly can. If you can't do this model, then you try to come up with the next best thing, which is going to vary from solution to solution, vendor to vendor, right? Hopefully, this solution, I've tried to point out some of the design goals in this solution. My recommendations, if you can't do this exactly, try to go ahead and do as many of these elements as you possibly can in your unique solution for each, the vendors that can't do this, to try to maintain as much security as you possibly can. So, final keepaways. Number one, if there's anything that I could advise, keep the internet and any element like it, like email, right, out of the control networks. Any type of laptop, right, that's in the control network, if you have a laptop or a machine that does active control, that machine should never leave that control environment, right? And machines outside of the control environment, when they remote access in, should never be able to use the software on those machines to be able to interact with the control systems themselves. We want isolation. Major takeaway number two, when you define an enforcement zone, remember, this is an area where we use a big magnifying glass. We want to limit traffic only to required approved traffic, and we want to collect and keep a record of all the traffic through that enforcement zone. Okay, that is our safeguard. That's the area where we can monitor it. Don't let virtualization, don't let Active Directory, don't let anything else through that area or through those enforcement zones. Okay, remember each level can and should be broken into subnets, and we can do flow control between those subnets themselves. You can do ACLs on layer 3 switches, ACLs on routers. Just be careful if you're doing it on layer 3 switches, right? General rule of thumb, you don't want a lot of ACLs on layer 3 switches, but 2 or 3 per subnet, very strategically placed, is amazing to make that soft chewy center very resilient to attack. Okay, recommendation specifically, if you work for an owner or operator, something like an electric utility or an oil company or a manufacturing company, right? If you're not using the PURDUE levels, please start using the PURDUE levels. The PURDUE levels are simply a tool. There's nothing magic about them, but it's a tool that helps us to describe where to place defenses and where your major risks are. We recommend first starting with that enforcement zone, building a demilitarized zone between the control network and the business networks. Once you're there, then start separating level 2 from level 3 and having a smaller, less intrusive enforcement zone between level 2 and level 3, at least so we can have a second place for visibility and a second place to possibly island in worst case scenarios of compromise of level 3. Recommendations to vendors: keep building products that fit in this layered model. And when you have documentation, please help or make sure you place in that documentation guidance to your customers to help them identify and understand where to appropriately place your products according to that PURDUE model. Okay, so that is the presentation. I wanted to also bring up a reminder, we do have ICS 410 that's running. We're running ICS 410 25 different times worldwide for this. I'll actually be in, let's see, we have Paul Henry teaching this in Japan, in Asia Pac here in the next couple of weeks. I'll be teaching this class in Singapore in March, right? And then we have several other runs in Australia and throughout Asia Pac, as well as the rest of the world. So definitely a lot of great information here with ICS 410. If anybody has any questions, I do have contact information here. Here's my email address, justin@controlthings.io. Feel free to go ahead and use that to contact me. And with that, I'll go ahead and I'll pass the control back to Ruby, and we'll go ahead and use the last 8 minutes or so to do any questions and answers for you. So if you have questions, please send them on in, and Ruby will read them to me.
Okay, so Justin, one question is, says, if AD is not extended below level 4, how do you implement RBAC in levels below?
So with Active Directory, if you need Active Directory and if you do want to have role-based access, right, you can place Active Directory down in the control network themselves. The biggest difference is you want to make sure you do a unique deployment of Active Directory at that plant. So it would be a separate Active Directory server with a separate domain that has absolutely no trust relationship back to the enterprise. So you can have role-based access and centralized authentication, just make sure it's not connected to the enterprise, because we don't want any compromise of the enterprise AD from spreading or using that as a mechanism to get into the control network.
Okay, the next question says, how do you envision the network layout where you have many 150 plus small plants linked using a single layer enterprise network? Many of the diagrams seem to imply a large management energy, as there's a ton of little bits and bobs to get things moving.
So read that question one more time to me, Ruby.
How do you envision the network layout where you have many small plants linked using a single larger enterprise network?
Yeah, so if you have many different plants, right? If you have many plants that need to be connected together, one thing that you can do is, first off, I would say, can you isolate each plant itself? If the more you can isolate each plant, the better the security capabilities you're going to have at each plant, right? Because then if you have one compromised plant, if it's completely isolated, it doesn't affect all the other plants. However, if you have a large number of smaller plants, you also gain benefit by sharing resources between those plants, right? So you may have like an Active Directory that spans multiple different plants that are there, or some historian that spans multiple different plants, or some other solution that's there. My recommendations for that is to use the same model that we had for SCADA, right? Just kind of implement that for what you would do for each one of the plants. What we would do for those situations is, according to the PURDUE model, we would have the connectivity to each one of those plants actually be connecting back to that demilitarized zone at each plant. And if we need to share resources between plants, say I have 5 plants and I'm sharing Active Directory between those plants, my recommendations is build a VPN tunnel between those 3 plants from level 3 to level 3 at each plant, and then allow Active Directory to share its traffic and its authentication or anything else through that level 3 network, right? So you still can have connectivity across the plants. We just want to make sure that it's securely done from level 3 to level 3 or demilitarized zone to demilitarized zone, so that we are not risking external compromise inside of the plants.
And the next question says, so for patching, for example, would you have a relay server in the DMZ from which the level 3 patching servers would pull from? Doubles compute footprint.
Yes, exactly. So let me give you a scenario with that. Say you're using something like Microsoft WSUS, right? My recommendation is I would put a WSUS server inside of the demilitarized zone to be able to collect the patches from the enterprise. And then I would put a second WSUS server inside of the security operations, the cybersecurity operations level 3 subnet, right? And have that machine be the one that actually does the patching. So if I need to patch something or approve patches, I log into the WSUS instance at level 3, and the way it gets its patches is that server in level 3 grabs them from the WSUS server inside the demilitarized zone. So 2 WSUS servers, the only purpose of the middle one is to literally hand off the traffic back and forth. So it can basically queue all the patches there, and then from the control network, the one we actually do the patching from, it can, as needed, go and grab those patches and update its patches when we tell it to. That just gives you further isolation from manipulation or attackers using that as an attack point.
Okay, the next one is, do levels 0, 1, 2 need to be in different subnets?
Do levels 0 and 1 and 2 need to be in different subnets? So in the diagrams that I had, in fact, let me go back up here, right? So what the question was is, with these subnets, do they need to be separated, or can I share level 0s across all the plants or all the processes, and level 1 across all the processes? You definitely can share across those process levels. There's definitely a benefit if you don't. If we isolate them, you do actually allow yourself to island each process, and you are limiting cascading failures from one process to the other process. But many plants were never designed that way, and many plants assume level 1 is the same logical network across the board, across all the manufacturing lines. So if you already have that established, then it's probably best to go ahead and stay with that. At that level, there's not a lot of security defenses we can place down there. So that's something I generally would live with if it's already been established at a plant. But if it's not too much effort, you should at least bring up the question on whether you can subdivide that per process, or maybe break it into 2 different groups of processes, because whatever you can do does further enhance your isolation between the processes. So live with it if you have to live with it, do what you can do, but that's not nearly as important as the other dedicated enforcement zones or the demilitarized zones that I've called out. So basically anything in red is the things you do first, and then all the other guidance are kind of secondary to the things in red in the diagrams.
Okay, this is a 2-pronged question. On an earlier slide, the network schematic example, you mentioned IT and OT defenders fight for control over their respective enforcement boundaries. Do most industry/organizations recommend or operate separate and dedicated teams? And what are some of the risks associated with combining these distinctly different functions?
Perfect question. Yes, so if you look at this diagram right here, right? So these are my demilitarized zone, and notice I have an enforcement zone above the demilitarized zones and an enforcement zone below the demilitarized zone. So this is where we would have, 2 different firewalls, 1 in each enforcement zone. Or if you wanted, you could have a single firewall which basically acts or does the job of both enforcement zones through a single device. So I mentioned, your question stems upon the fact that I mentioned that often we have 2 firewalls for political reasons, because we have an enterprise team that's managing one side, and then we have an ICS cybersecurity managing the other side. As of right now, I would say about 50% of the companies, well, I would say most of the companies out there have tried to unify all IT and IT cybersecurity efforts into a single team. The problem with that is those team members generally do not understand the specific needs of the ICS zones or the delicate nature of the ICS areas, and so it actually leads to a lot of problems. from a cybersecurity perspective, I do recommend that you have a separate ICS cybersecurity team that is separate for the ICS zone than the rest of the enterprise. I don't care if they report through the same manager. I don't care if they are two sub-teams of a larger enterprise cybersecurity team. The biggest thing that I would recommend is, from a cybersecurity perspective, make sure you have dedicated individuals who are the individuals that only do ICS work, right? So if you need to have some type of security monitoring or operations or architecture set up, it's somebody from that ICS cybersecurity team, right? So I don't care how the management above that is, right? But I do recommend having dedicated personnel that these are the only ones that do work inside of ICS. And also, when I talk to CEOs and CIOs and CSOs, I do recommend for the IT teams to be the same way as well, right? If you have a networking enterprise team that does all the routers and the switches, say you have 20 people that does enterprise networking, I do recommend taking 3 or 4 or 5 people from that enterprise team and make them the dedicated resources for industrial control networks. So they may be part of the larger team and they share the same technologies and resources and the same, maybe even the same management, but those individuals, right, are the only individuals that deal with networking inside of the control networks themselves. That allows us to have specialized training for those individuals, and more importantly, it allows these individuals, both the cybersecurity teams and the ICS security teams that are dedicated resources, it allows them to build better relationships with the engineers and actually build better partnerships with the engineers in how to do secure communications and secure cybersecurity defenses in our control networks.
Okay, this one says, what type of enforcements are used for access to safety systems?
So with safety systems, as I mentioned, the most safe safety system is the one that's been disconnected from any communications from the other networks, right? I love to see safety systems completely air-gapped and islanded, meaning that the only way they can be modified is an engineer takes his laptop, walks physically to the safety system, physically plugs into the safety system, and makes its modifications to it, right? That's the most safe scenario. However, that's not always possible, because sometimes safety systems may need to communicate with the primary logical controller to let it know, for instance, when you have a trip and the safety system seizes control of the process, right? The safety system may need to inform the primary controller that it has seized control, right? So if you do have communications and requirements for communications between the safety system and the primary controllers, my recommendation is to find some type of an enforcement there. Right? So number one, I would recommend trying to do a direct communication cable from one to the other, and don't plug it into a shared Ethernet switch where attackers may find alternate ways to get to the safety system. You may also want to consider something like some type of an ICS firewall between those two that can filter traffic going back and forth to the safety machine or the safety system, or maybe even a unidirectional gateway protecting that safety system. Remember, if there's anything you want to protect inside of the control network, if you lost everything at the control network, if you can at least save the safety system and keep the attackers away from the safety system by itself will prevent worst case scenario, right? If you lose that safety system, the attacker can create worst case scenario. So your number one thing, the last thing that you want to make sure the attackers never get to is that safety system. It's what prevents worst case scenarios.
Okay, looks like we just have 2 or 3 more questions.
Okay, excellent. Yeah, I don't mind going over at all. I have the time.
Okay, if you have outsourced managed SOC for OT, what would be the best approach? That is, the SOC is remote managing the OT network security.
So anytime that you're doing, so if you have a SOC, right, inside of the enterprise at level 5, or maybe even a third party that's doing it through the internet, right, my recommendations is that you still house your primary cybersecurity operations servers inside of this cybersecurity operations subnet in level 3 of your plants, right? So put your actual physical servers there that collect all the information and do the final level of control. For SOC operations, right, in a perfect world, we would be able to have our own cybersecurity SOC for the ICS environments, there's very few companies in the world that have a big enough cybersecurity team to do their own ICS cybersecurity SOC. I have one or two customers that have that size of a team, but that's fairly rare, right? What my recommendations are, if you have a limited number of individuals, well, first off, I would recommend you have a couple cybersecurity professionals that are dedicated employees doing cybersecurity operations for your organization, at least at a higher level. Then what I would recommend is if you want to outsource maybe the level 1 reporting or the initial investigation, right? Take a subset of whatever you're collecting here in your cybersecurity operations, push that back out through that ICS demilitarized zone, right? A subset of the events, a subset of the logs, push that to the ICS demilitarized zone, and then have the business pull that into your enterprise SOC, right? So then they can go ahead and do level one alerting from that enterprise SOC themselves. I would not, and I repeat, I would not let your enterprise SOC or a third party for that matter, allow them to reach back through the demilitarized zone into your cybersecurity operations inside of the control network themselves. I would not let that to occur at all. What I would require them is if they did find some type of a compromise or had some type of an incident that they felt that was a valid incident they wanted to declare, that they then hand that back to the cybersecurity individuals that deal with operations inside of the SOC. So, have your dedicated small team do the actual cybersecurity operations in the control network and only send the outside world a subset of the events to give them just enough to do level 1 reporting. So it's kind of the same thing that most companies would do to an enterprise or like an internet-based third-party MSSP, right? We have them do level 1 alerting, and then they escalate it back to the enterprise IT security team. We do the same thing. We use the enterprise security team to do level 1 identification, and they escalate it to the ICS cybersecurity team, and then only those few individuals on the ICS cybersecurity team log into the actual operation server to do the escalated incidents.
Okay. It says, sorry. Can you elaborate further on the increasing use of OT in the cloud? For example, IoT or cloud-based services where the field devices also need to be connected at a field/control level to the rest of the local control system network. This makes a cloud DMZ a little difficult.
It does. The cloud DMZ does make some things very interesting. Like, so for instance, recently one of our customers is a large electric utility of North America, and they have been deploying brand new utility-sized battery storage that goes into a substation and provides enough storage to allow, X number of homes to literally run off of battery power from the substation for a period of time. So Tesla is one of the only companies making these enterprise scale batteries, right? And so these systems are being placed in the subnet or in the substations, and they technically are a layer 1 device. In fact, let me jump down here. Let's see, where would be a better diagram here? Yeah, I think that's probably the best diagram I have in the slide deck for this. So that becomes really, that battery is a level 0 device, and they have a controller connected to it, right? So all of those batteries through Tesla actually have to be connected through Tesla's cloud, and Tesla can directly connect to those batteries themselves, right? And that actually is occurring down here at a level 0 network. My recommendations when we try to build the security architecture when I was working with my customer with this model is we still leverage that demilitarized cloud if it needs to go across their internet links, right? And we basically will build a single firewall rule from that cloud-based DMZ saying that through the firewall, they can only talk to the small number of IP addresses at level 0 at each one of the site where they can get to. So by using the PURDUE level and using all these enforcement layer, I can limit communications from that cloud directly down to PURDUE level 0, right? Without the risk of an attacker compromising the cloud and accessing everything else inside of the control network. So that's my recommendation. Still have them connect through that cloud demilitarized zone, and then from that cloud demilitarized zone, build little tunnels or what 62443 calls channels. Have them basic or conduits, 62443 calls them conduits. build that conduit or a VPN or some type of a network link so that it just directly connects right to the device that they need to manage themselves, right? The biggest goal here is we just want to make sure that we are minimizing the risk of an attack coming through the cloud solution from affecting the rest of the plant.
Okay. Are 802.1x technologies used for remote access?
802.1x. So 802.1x generally is going to be that lower level authentication that's happening down at that switch level. That can be tied into your solution, but 802.1x itself is not ever a direct technology for remote access. So that's not something you're going out and buy 802.1x solutions for doing that, right? You can, if you want, you can try to do that switch authentication 802.1x. You can do that switch authentication layer if you really want once a VPN back in, or maybe that becomes as part of a VPN solution for the final stage or the final layer. But that's not anything that's ever sold as a standalone device for remote access. It's usually a technology layer in all the other security solutions that's out there. So I hope that kind of answered that question, because that question was maybe a little bit off from how 802.1x is usually used.
We are looking at placing a SIEM in ICS operations environment. Now this SIEM system is having ability to showcase dashboards on mobile applications. Achieving this means some dashboard information travel outside ICS over internet. What do you recommend? Bad idea?
Yes, bad idea. We don't want to have any type of SIM traffic being pushed outside of that control environment, especially through the public internet to mobile devices, right? We should definitely remember this environment is a highly secure environment. Just ask your business what happens if you lose one of the plants, and you definitely don't want to be the cause or the one that created the bus lane for the attackers to drive their explosives into your virtual plant here through these virtual links. So yeah, I definitely would not do that. I would require anybody that wants to do visualization of the SIM or the SIEM solution that's there, require that they do the same remote access process that we require everybody else to make their way all the way into the control environment. And then from that stage, then they can go ahead and access the SIEM solution for any type of visualization or dashboards.
Okay, and then this is the last question. If I think it's related to a previous one, possibly. If the level 0 device has a modem inbuilt through, for example, LTE that connects to the cloud, you can't route this through the DMZ cloud?
You're correct. And specifically, I didn't really go into a lot of details in the example I mentioned about the Tesla solution, but that's exactly how the Tesla solution works. These batteries themselves has a little controller, a little device attached to them, and that has a LTE modem built into it. And so Tesla is literally dialing directly into these level 0 devices, right? And that's the only way that these devices are done. If you don't accept that, then you can't deploy these devices. Tesla will not support a contract with you. So you basically have to accept that vendor's requirement to do LTE dial-in to level 0. My recommendations there is you build Fort Knox around them. That's why we have all these other enforcement zones, is where you basically try to treat that battery as its own little enforcement zone, right? And just assume that attacks can come through that LTE connection to the level 0 device, and we want to build an enforcement environment around it, assuming that it will be compromised, and that if it does get compromised, the attacker can't get anywhere else outside of that area.
Okay, well that looks like that's it. Justin, thank you so much for your great presentation and for bringing this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, visit sans.org/webcast. And if you have any questions, feel free to contact us at asiapacific@sans.org. Until next time, take care, and we hope to have you back again for the next SANS APAC webcast. Thanks, Justin. Any final words?
Nope, that's it. Hope to see you guys as we're floating around teaching these classes. So don't be afraid to reach out and say hi, or drop me an email with the email I provided.
Great, thanks. Have a good day, everyone.
See you guys.